In this lesson, I'm going to take a look at finding volume, and I'm going to find the volume of a prism and of a cylinder. But the first thing we need to look at is what is volume. So what you want to remember is volume is the amount of stuff or the amount of space that a figure takes up. All of that space that's inside of the figure. And it's always going to be measured in terms of cubic units. In other words, how many little cubes fit inside, and it's going to be a 1 inch, or excuse me, not 1 inch, but 1 unit by 1 unit by 1 unit. Now that might be 1 inch by 1 inch by 1 inch, it might be feet, meters, it could be anything. But it's always that kind of size cube. You're trying to figure out how many of those fit inside of the figure. So I come here to this rectangular prism, and many of you have found the volume of a prism like this, and many times you'd go through and you'd take and multiply 5 times 3 times 4 to get a volume of 60 cubic inches. So if I had cubes that were 1 inch by 1 inch by 1 inch, I'd be able to get 60 of them inside of that prism. Now what I want you to realize is really what we just did there is we found 5 times 3, which when you look at that, those are the dimensions of this, what I would call the bottom in this case. Now it doesn't always have to be the bottom, but I'm looking at it as, call it the base of my figure, of my prism, and then I multiplied it by the 4, which is the distance in between the two bases of the prism, which would be referred to as the height. Which leads me into this next one, which is just your formula for the volume of a prism. Now here I have a triangular prism, but it will work for any type of prism, and we can find that by calculating the area of the base, just like I did on the last one. So in the one that I have here now, it would be a triangle. You'd have to find the area of a triangle and then multiply it by the height of the prism. Now remember, here's what you got to remember about the height of a prism. It is always the distance between the bases. And that might help you remember what the height of a prism is. Now what I want you to notice here is this volume formula. It says volume equals B times H. Now notice that's a capital B. Anytime you see a capital letter, that's going to refer to area. So this is the area of the base. Don't confuse that with the length of the base, which you'd need to know to find the area of the triangle. So there's two different bases that are going to be going on in finding a volume of that prism. One, the area of the base, so the area of the triangle, and two, the length of the base of the triangle. Keep those two things straight because they are definitely different. Now if you go to the volume of a cylinder, well, being the cylinder is kind of like a prism, your volume's not any different. So really, if you don't want to write anything on this, you could just go back to the previous one and put volume of a prism and a cylinder. It's the exact same thing. Now, some books will give you a different formula because they'll give you the formula for a circle for the area of the base, and they'll put pi r squared h. And if you want to do that, that's fine. It's totally up to you. But remember, your base is in a cylinder. It would be the two circles, so I'd find the area of that. And then the height of the cylinder, remember, is that distance between the bases, right there. And then I'm going to look at, well, how do we find the volume of an oblique prism or an oblique cylinder? What I've done is usually I pull out the quarters and I show them to the students, but what I've done here is I've taken a picture of those. I have a stack of quarters, so in the first one here, I have a cylinder. It's all stacked nice. And I could find the area, or the volume of it, by finding the area of one of the quarters, and then multiplying it by the height of that cylinder. Well, I haven't taken any quarters off or added any quarters, so what that tells me is the volume of these two cylinders is going to be equal. And being their quarters here, and I haven't added or deleted any, the height of this cylinder is not going to be any different than the height of this cylinder. So it leads me to believe that if I found the volume of this cylinder by doing the area of the base times height, I should be able to find the volume of this one the same way, area of the base, because they're equal and the heights are the same. So all I'd have to do is take the area of the base and multiply it by the height. So when you look at this, if it's an oblique cylinder or an oblique prism, your formula is not any different. It's still going to be volume equals area of the base times the height. Just remember that the height is the distance between the two bases right here. Don't confuse that with this. That is not the height of the prism or the cylinder in this case. And then that's going to conclude the lesson portion on volumes of prisms and cylinders.